Good morning, students. I hope all of you understood the first three questions from the exercise 8.2. So today we have to start the next one, which one is question number 4. As you see, the question is given here. The question is given ABCD is a trapezium in which AB parallel to DC. BD is a diagonal and E is the midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F. As you see, the figure is given here, so that F is the midpoint of BC. So in this case, we have to prove F is the midpoint of BC. We need to prove here, isn't it? So now, in this case, the question is given here, ABCD is a trapezium. So what is the property of trapezium? In case of trapezium, we know the opposite sides are always parallel. So that's why here written AB parallel to DC. Is it clear? And here also mentioned BD is the diagonal, isn't it? BD is the diagonal and E is the midpoint of AD as present here. So now here we have to start this one. Let's see how can we do this. So a little bit construction here we have to do. And the construction is like in this way, if you see this one. So here AB parallel to CD, and now in this case, in this side AD, E is the midpoint mentioned, and through this E we have to draw a line parallel to which side? Parallel to AB, and this line intersecting BC, that means this one is the BC at F, and this F we need to prove the midpoint of this BC. So here when we draw a parallel line EF, so obviously this line intersect the diagonal BD at one point, and which one is we denote by here Z. Is it clear? This one is the construction. So that's why here first you see written let EF intersect DB at G. Is it clear? Okay. Now after that, next you see one more property we know, the converse theorem or midpoint. So the converse theorem is what here? A line drawn through the midpoint of any side of a triangle and parallel to another side bisect the third side. That means the property is what here? What is the meaning of this line here? The meaning is, suppose if we consider a triangle here, suppose this one is the triangle ABD, for example, and now here in this side E is what? E is the midpoint. So through this E, when we draw a parallel line and this line parallel to the another side, that means AB, and when we draw this line bisect the third side, that means this one is the first side, this one is the another side, and in this case we consider this one is the third side, so bisect third side, that means this point Z separate this BD into two equal parts. Is it clear? This one is the meaning of the converse of midpoint theorem. So that's why here if you see written in triangle ABD, here one thing we know, EF is parallel to AB already given. So if EF is parallel to AB and E is the midpoint of this AD, so automatically by the converse of midpoint theorem, Z is what? The midpoint of this BD. Is not it? Because this line is parallel to this side, so obviously this line bisect the third side according to our statement we know. So that's why Z is the midpoint. Is it clear? So now here if you see EF parallel to AB, as well as one more thing given, since it is a trapezium, so obviously AB is parallel to DC or CD. So if these two are parallel, and already we write here EF is parallel to AB. So that means from here what we can say? This EF is line is also parallel to this CD, because AB is parallel to CD and EF is parallel to AB. So that means this EF is also parallel to CD. Is it clear? Okay. Now, if you see the next one, after getting this G is the midpoint here. If you see the another triangle here, and in this time the triangle is we consider BCD. This triangle we consider now. In this triangle BCD, already we proved G is what? Midpoint. And already we know EF is parallel to AB. If EF is parallel to AB as well as AB is parallel to CD, so from here what we can say? This GF is also parallel to CD. If GF is parallel to CD and G is the midpoint of this BD, so from here easily we can say this F is also the midpoint of this BC from the converse of midpoint theorem, is not it? Because in triangle BCD, GF is parallel to CD and G is the midpoint. So if G is the midpoint, from here easily we can say F is also midpoint. Is it clear? Very simple question, and this one is our proof. Hence our proof is complete here, because the question is given, prove that or show that F is the midpoint of BC. So already we proved here. I hope all of you understood this one. Has not it? Okay. After question number 4, now if you see the next question, question number 5, and the question is given like in this way: in a parallelogram ABCD, E and F are the midpoints of sides AB and CD respectively. As you see, the figure is also given, and now here we need to prove AF and EC trisect the diagonal BD. That means here AF and EC trisect the diagonal. Trisect means what? Equally separate into 3 parts. Trisect. Bisect, equally separate into 2 parts. Here trisect, equally separate into 3 parts. Isn't it? This one is another very simple question. Now let's see how can we start this one. So now in this case, if you see the diagram is here, first of all given here A, B, C, D. This one is what? This one is a parallelogram. So if A, B, C, D is a parallelogram here, one thing we know, opposite sides are equal and parallel, as you see here. So that's why here we write first of all AB parallel to CD, as you see here. AB parallel to CD, isn't it? So if AB is parallel to CD, or whatever we write DC, same thing. So in this case you see, from here we can say AE also parallel to FC, because these two are on the same line, isn't it? So that's why here we write AE parallel to FC, you see here. Again, one more property we know. In case of parallelogram, opposite sides are equal and parallel. So first we write parallel, now we write equal. So in this case we write AB is equal to CD, this one. And now here E is the midpoint and F is the midpoint. So that means these 2 parts are equal. Only for that reason here we have to multiply both sides by 1/2, half of AB. If we write multiplying both sides by half, then half of AB. What is the part of half of AB? Either we can write EB or we can write AE. But here we need this AE part. So in place of half of AB, we write AE. As well as in place of half of CD, we write F of C. If we write DF or if we write EB, then it is also correct. But we need AE and FC, that's why we write these 2. Understood this one? Okay. Now, after getting this one, what we get? AE parallel to FC we get, as well as AE equal to FC we get. Now if we consider this triangle AECF, in this triangle already we prove AE parallel to FC as well as AE equal to FC. So obviously if opposite sides are parallel and equal, then it is what? A parallelogram. So that's why we write here AECF is a parallelogram. You see here. So if it is a parallelogram, then again we write opposite sides are equal and parallel. Now this time we write these two. So that's why in this case we write AF is parallel to EC. Is it clear? Okay. Now after that the main part is come here. After proving AF is parallel to EC, now here we consider the triangle DQC. Listen carefully, DQC. This triangle we consider. In this triangle DQC, inside DC, F is what? The midpoint. F is the midpoint. And here, FP or PF, whatever we write, FP and QC, these two are parallel. FP and CQ are parallel. You know why? Because already we prove FEC are parallel. If these two lines are parallel, then this part is also parallel. Isn't it? So that's why in triangle DQC, if F is the midpoint and FP and CQ are parallel to each other, so from here what we can say? By the converse of midpoint theorem, P is also the midpoint. Isn't it? If P is also the midpoint, then in this triangle you see DQC, if P is the midpoint, DP is equals to PQ. Isn't it? Because P is the midpoint. If P is the midpoint, then these two are equal. Understood? Okay, now we put this one as equation number 1. Next, again, if we take another triangle, the second triangle is here we consider APB. In this triangle, again in the side AB, E is what? The midpoint. If E is the midpoint, and here you see AP is parallel to EQ, because AF is parallel to EC, so that means these two sides are also parallel. And if E is the midpoint and if AP is parallel to EQ, then what we can say? By the converse of midpoint theorem, Q is also the midpoint. If Q is the midpoint, then in this triangle APB, PQ length and QB length, these two are what? Equal. So PQ equals to QB. And then we put this one is equation number 2. Now if you see the equation number 1 is dP equal to PQ. And the equation number 2, here we get PQ equal to QB. So if we compare these two, then what we can write? dP equals to PQ and PQ equals to QB. Ultimately, all these three parts are here equal or not? If all these three parts are equal, that means what we can say? This diagonal BD trisect in three equal parts. That's why our conclusion is here finally written. Hence, the line segment AF and EC trisect the diagonal BD. Is it clear? I hope all of you understood this one. So today we complete two questions, question number 4 and question number 5. So you have to copy these two questions, and in our next class we have to continue this exercise. Only 2 questions left from this chapter. Is it clear? Okay, thank you.